Good morning, everyone. I welcome you all for this session of projection of solids. Without wasting much of our time, we will start with the problem which is displayed on your screen. The problem statement goes like this. A square pyramid, 35 mm sides of base and 60 mm axis length, rests on HP on one of its corners of the base such that the two base edges containing the corner on which it rests make equal inclinations with HP. Draw the projections of the pyramid when the axis of the pyramid is inclined to HP at 40 degree and appears to be inclined to VP at 45 degree. When I read the problem, it is a square pyramid and the base of that square pyramid, the length of that is 35 mm and the axis length is 60 mm and it is resting on HP. I can answer where it is resting. It is resting on HP. And how it is resting? It is resting on one of its corner of the base. So what I have to do is I need to have a corner on my right hand side. I need to have a corner on my right hand side of the drawing. So let's begin with the solution. The solution of this, let's start with my XY line. Write down vertical plane and horizontal plane, that is VP and HP. Then it is resting on a corner. So I need to have a corner on my right hand side on HP. So I'm drawing a square of 35 mm side, which is this corner, one of its corner should be on my right hand side. By drawing, extending this line and a line of with straight line and writing it down with the arrow marks of 35 mm. Then I'm going to name the base of it. It is A, B, C, and D. Then I need to find out the midpoint of the square. The midpoint of the square will be found out by joining the opposite corners of the base. So from A to C is the opposite, from B to C is the opposite. So this is my center point. Then I get O1 as my upper surface point and O2 as my bottom point. Then I'm going to project it upwards to my XY line. Then I'm going to draw the axis line whose length is 60 mm. The length of this is 60 mm. And pyramid is nothing but a line joined from the apex of this to the base corner. I repeat, a pyramid is nothing but a slant line joining by the apex of the top corner to the base corner. We call it as a pyramid. So then I'm going to join all the lines from the apex to this corner, from this apex to this corner, and from this apex to this corner. So now my axis line, which I had drawn earlier, is going to merge with this slant edge line, which is running from this top apex to the bottom corner. That is, it is running from this point O1 to this point D. This O1 to D, it is merging because I get a corner at this point. When I go along this line, I get O1 and O2 merging with this point corner D. Also, I get the corner B merging with D. So all these which are on this line, which is coming on this line, will be merging with this corner D. So the axis line which I had drawn earlier, it is not visible. Now only visible things are three darker lines what I get. And also I need to do the namings. So this corner is visible, so it is A dash. This corner is visible, so it is D dash. this corner is visible, it is C dash. Now the non-visible things for me are, this B is coinciding with D, so it is B1 dash within the bracket, and O2 is not visible because it is coinciding with D, so that will also be within the bracket O2 dash, as well as I can see O1 from the top, so it is O1 will be visible always. Now when I have completed this whole thing, I need to go to the third one, that is I have an axis of 40 degree to HP. I have an axis inclination here which is 40 degree to HP. Again in this case, what I'm going to do is I'm going to convert this axis inclination to the base inclination with the triangle method, that is 90 minus 40 is nothing but 50 degree. So what I'm going to do is somewhere on this XY line, I'm going to draw a line in this way where the angle of this line in this case will be nothing but 50 degrees. So when I do so, I have an axis which will be automatically converted to 40 degrees. So I draw this line. This is the line which I'm going to draw first at 50 degree angle. That is, this is 90 minus 40 will give me 50 degree angle. So somewhere on this XY line with this point, I'm going to draw a line of 50 degree. Then what I'm going to do is, I know from point C dash to D dash, I know the distance. On this line from C dash to D dash, I cut the arc here. I measure from here in this front view, from this front view, I measure from C dash to D dash. From C dash to D dash, I measure it. I cut this down. Then from C dash to A dash, I measure it. From C dash to A dash, I measure it. I cut this down. Then with this point, I draw a 90 degree line. From this point, I draw a 90 degree line here. From this point, I draw a 90 degree line. When I draw a 90 degree line, then I measure this line at 60 mm. This line, whatever I have, it is nothing but the axis line. This line I'll be getting as 60 mm. So at 60 mm, I cut down this line at this point. Once I get a point that is nothing but O1, from here I join to A dash, and from here I join it to C dash. With this, I can complete this whole uh, triangle with this part, and also I draw a line from this point, that is O1 dash to D dash. Once I do complete it, the same naming whatever I have in the front view will be the same naming whatever I'm doing it here in the triangle. Then I'm going to project it from the top to bottom and the sideways. This is the projection in the from the top view to the sideways. Then I'm projecting this whole thing from the top to the bottom, that is A to A and B to B, C to C, and D to D. So I know all the points, and this is O2. I know all the points. I just project it. I name it. That is A, B, C, and D. And also I need to name this O1 and O2. Then I'm drawing this axis line, which will be again merged. Now the first thing what I'm going to do is, I'm going to join the outside part first. I'm going to join the outside lines first. To start with, from O1 to B, I'll join it. From O1 to B, and B to A to B, and A to D, sorry, and D to O1. Always the outside lines will never be hidden. It will always be a thick line. So it will be drawn with the first thing what I'm going to draw is the outside lines. As in the previous case in prism, I had a face here. That face I used to draw it first. In this case, I don't have any face. I'm starting from the apex to this base corner, then this base corner here and here. this whole thing outside part, I'm going to draw it first. Then I go to O1 to A dash. That is this part, that is O1 to A dash. This is very, very visible for me. So what I do, O1 to B dash, I O1 to A dash, I just join that line. O1 to A dash will be a thick line which is visible always. O1 to A will be visible, so I'm joining that line later. First is I'm joining the outside parts with the thick line. It will never be dotted lines. So I know the outside line, it is from A to B, A to D, and then the slant edges, that is O1 to B and O1 to D. These are my outside lines which I get in this pyramid. This is what the first, whatever line I have got, that is O1 to A dash, that is O1 to A, it is always visible. So I'm drawing a thick line. Now I come back to find out my hidden line. Line going out from this point C dash will be dotted. That is the hidden line. It will always be hidden line. Line going out from this C dash. Line going out from C dash, it is C dash to O1 dash. Then it is C1 dash C dash to B dash, as well as C dash to D dash. That is nothing but from here it is C to B and C to B and C to D and also C to O1. Already I have drawn O1 to A, it will always be starting with this line which is visible, which I have already drawn. Now only two lines I have to draw, that is nothing but C to B and C to D. Again it will be in a Y shape, but this Y, that is the longer edge, that is C to O1, is merging with the line O1 to A. So in that case, I'm getting only these two lines as my hidden line, and it will be a dotted line which I'm drawing, that is from C to B and C to D. That is what I'm going to draw. Then in the next part of the problem, again I have axis inclined at 45° to VP, but it appears to 45° to VP. When I go back and read the question, I have and appears to be inclined to VP at 45°. It is appears to be inclined to VP at 45°. So in that case, I have appears to be word, and when I see the axis length in this case, that is from O1 to O2 in this diagram and O1 to O2 in this diagram, it is nothing but it is changing, that is from 60 mm to this length. O1 to O2 in this diagram and O1 to O2 in this diagram, from 60 it is reducing, the length is reducing. Since the length is reducing, I get a angle which is with respect to the locus problem. When it is a locus, again I need to go back and check in the question whether I have appears to be in the question. If I have appears to be, then it is, I'm not going to use any locus method, directly I'm going to draw it. So it is appears to be, so whatever the diagram I have, this axis O1 to O2 has to be on this 45-degree line. So what I do, I draw a 45-degree line. Then I complete this square or a rectangle, whatever I get. In this position, I get a rectangle starting from this line, whatever I have got, I extended. This point, whatever I have here, I extended to this point, and this line I extended to this point. So this point I'm taking it as 1, this point I'm taking it as 2, this point I'm taking it as 3, and here I'm taking it as 4. This whole thing, whatever I get, this whole rectangle, whatever I get, I'm going to place it in such a way that O1 to O2 has to be on my 45-degree line. So it is very simple. Now I come back to the question. I just place this O1 to O2 on this 45-degree line. When I do so, it will be on this 45-degree line. Then I need to project it, name this whole thing, whatever I'm placing it. I need to project on top A to A. This point is A, then I have B to B, then I have C to C, D to D. So I've got A dash, B dash, C dash, and D dash. Then I need to project the apex on top. I'm just closing it with the bottom surface. Then O1 dash and O2 dash I project it, and I name those O1 dash and O2 dash. Then I'm going to join the axis, then all the lines. That is from O1 to A dash, O1 to B dash, O1 to C dash, and O1 to D dash. Now I see from here, from this end, from my cursor end, which is the farthest base corner, because it is the apex. So I cannot talk about the apex, only I'm going to talk about this base corners, which is the farthest base corner in this case. A is not the farthest, D is not the farthest, nor C is the farthest. The farthest base corner in this case is nothing but B. In that case, what I'm going to do is, I'm going to just, the line going out from B will always be dotted. But since this is the visible from me, from this end, I can see A, I can see B, I can see C as well as D. This whole thing, when I can see, it will never be dotted. Only thing dotted is all the lines going out from B has to be dotted. That is the concept. But this bottom base is all visible. Only the line which is not visible is B1, B dash to O1 dash. So that will only be the hidden line. So I'm going to draw it with the dotted. So with this, I complete my solution. So next, let's go to quickly rush. We are having another 15 minutes. So let's quickly run with, we will solve another problem in this class. Goes like this. A square pyramid of 35 mm size of base and 60 mm axis length rests on HP on one of its corner of the base such that the two base edges containing the corner on which it rests make equal inclinations with HP. Draw the projections of the pyramid when the axis of the pyramid is inclined to HP at 40 degree and VP as this problem, and this problem is here I roll. So let's quickly run with the solution. XY line VPHP, it is resting on the corner, so I should have a square in such a way that I should have a corner on my right hand side. Then I'm going to do the dimension, the name it ABC. Then I'm going to name the apex axis of 60 mm, measure 60 mm, join this rectangle. Now, one major thing I need to know here is these slant lines which run, I'm going to name it the same namings what we did in the previous problem. That is A dash, D dash, and C dash are visible. A dash, D dash, and C dash. These three corners are visible, so they are outside the bracket. B dash is within the bracket, as well as O2 dash is within the bracket. Then one dash is visible for me in the front view. And also I should be knowing the slant edges. It is the slant edge which runs from the apex to the base corner, that is from O1 dash to so in that case, always I'm going to draw that O1 to A, O1 to B, O1 to C, and O1 to D. These lines which are seen from the top, these lines are nothing but they are the slant edges which run from the apex to the base corner, which run from the apex, that is, this is the apex to the base corner, that is O1 dash to A dash. So these slant edges, when I see from the top, they are always visible. They are always visible. So in that case, what I'm going to do is this O1 to A dash is, that is O1 to A. I'm going to draw it with the thick line, the same as I'm drawing it with the outside base edges, as well as O1 to B, O1 to C, and O1 to D. These I'm going to draw it with a thick line only. In the prism, what used to happen was my top base used to coincide with the bottom base, where I didn't have the longer edges was always merging with the top base. So in that case, if I didn't draw these lines, was so once that is done, then I have an axis inclination, which this axis is been, which this axis will be always converted to a base inclination, where I draw the same manner from measuring from C dash to D dash, C dash to A dash. Then from here, I'm going to draw a 90-degree line, measure this with 60 mm, cut this down. This is my apex O1 dash. Then join the lines from O1 dash to A dash, O1 dash to D dash, and O1 dash to C dash. Then I'm going to project all these, name it, and then I'm going to name the outside edges. Then these corners, I'm going to name it with A to B, B to O1, O1 to D, and D to A. Then O1 to A is visible, that is O1 to A dash. This line is always visible, that is O1 to A is always visible, which I have already drawn. Only thing is line going out from this corner is not visible, that is C dash to B dash and C dash to D dash, as well as C dash to O1 dash.
So to B, C to D, and C to O is dotted, but this dotted line is not visible because it merges with O1 to A line. So I get only two lines here.
Axis inclination of 30 degree to VP. That means when I see the axis length from O1 to O2 in this fourth diagram and see the axis length in from O1 to O2 in this first diagram, it varies.
So from 60 to, it will be something lesser than 60. That means I go back to the question and check appears to be words. So if I don't have appears to be, that means it will be a locus problem. So in that case, what I do is I draw a 30 degree, whatever is given in the question. The axis is inclined to 30 degree. In that case, what I'm going to do is I'm going to measure somewhere on this 30 degree. I'm going to measure the true length. True length is that is 60 mm. Once I draw that 60 mm, I'm going to draw a line of that is the locus or from the which will be parallel to my XY line. A locus which will be parallel to my XY line. At this point, I'm going to measure this O1 to O2 here. That is, this point is O1. Then I'm going to measure O2 in this problem. So in that case, I'm going to draw a line from this point to this point, which I'm going to cut this. Before I draw this line, from this point, I'm going to measure from O1 to O2 in the fourth diagram. From O1 to O2, I measure it is from the fourth diagram. From O1 to O2, I cut this locus. Wherever it cuts, that is my point, new point O2. So, and this is my new point O1. So with that point, I'm going to again construct this diagram. This diagram again, I'm going to construct it in such a way that I'm going to draw it with the help of a rectangle. That is, from here, I'm drawing a 90 degrees line, and from here again, I'm going to draw a 90-degree line. This whole thing I'm going uh, to measure it from this line, whatever I get, and I am going to place it, then I'm going to name it. Once I do it, I'm going to project from A to E, then I'm going to base. When I see from here, this point is visible. This base is visible, so it is the base which from here it is visible for me. Then I'm going to draw O1 to O2, then I'm going to join O1 to A dash, O1 to D dash, and O1 to C dash. And I'm going to observe from this end, which is the farthest corner, because it is resting on only one corner. So I need to find out only one corner in this diagram, in this fifth diagram. Farthest corner in this case is B will be dotted. So I get all the lines going out from D will be dotted. B will be dotted. So B to O1. So I draw B to O1 as dotted. But I have another two lines, B to A and B to C. These are the two lines which are the base lines, and these base edges is from this end. I'm going to, it is visible. So in that case, it will not be hidden. That is B dash to A dash as well as B dash to C dash. It will not be a hidden line. Only one line which will be hidden for me. It is nothing but B dash to O1 dash. So with this, we complete one more problem. We have another 2 minutes left. If any of you have any doubts, you can just ask.